Half a day students, today we're going to be going over polynomials, at least the first part of polynomials. We're going to be going over the rules of exponents to review, different types of polynomials, and then finally adding and subtracting them. The next video we'll talk about multiplying. So to review quickly on exponents, we actually have what we call a power. So 2 raised to 5 is a power, where 2 is our base and 5 is our exponent. The exponent tells how many times the base is used as a factor. So I'm going to multiply 2 to itself, and I'll have a total of 5 factors. So this 2 raised to 5 just means 2 times 2 times 2 times 2 times 2. And the rule basically for this class is if you can find the answer, meaning to say if I can find 2 times 2 times 2 times 2 times 2, then you actually have to do that answer in that final simplified form. So 2 times 2 is 4, times 2 again is 8, times 2 is 16, times 2 one final time is actually going to equal to 32. However, if we have a variable raised to an exponent, obviously if I'm not given the value of this variable, I can't actually find the answer for that, but I do know that x raised to 4, I know that it's basically just x times x times x times x. So that's pretty much what we need to know about exponents. We're going to be going over the rules of exponents too, because it's very important in the next few slides. So looking at the first rule of exponents, when we have x raised to a times x raised to b, it's going to equal to x raised to a plus b. So when like bases are multiplied, we're going to add our exponents. And this is basically shown because x raised to 3 is just x times x, right? X squared is x times x. And all these together, I have 1, 2, 3, 4, 5. This is equal to x raised to 5. So that's actually how they got the x raised to 5. But now that we know the rule, we're actually just going to using the rule instead of expanding and then counting. So here we have x times x squared. So keep in mind that whenever you have a variable or a number and there's no exponent, it's understood that the exponent is just 1, right? So I can just say this is x raised to 1 plus 2, which is x raised to 3. The same thing goes for the 2 squared and 2 cubed. So we have 2 raised to 2 plus 3. We're adding our exponents. This comes out to 2 raised to 5. And again, for this class, you do need to give the final answer for that, where 2 raised to 5 is just 2 times 2 times 2 times 2 times 2, 2, 4, 8, 16, 32. And please make a point to box your answer so it's easier for the TA to find your final answer, and me when I grade your final. 10 squared times 10 cubed. 10 raised to 2 plus 3 again, which is 10 raised to 5. 10 is really nice because when you have an exponent of 10, all you have to do is just put that amount of zeros. So 10 raised to 5 is actually 1 with 5 zeros following. 1, 2, 3, 4, 5. 100,000. The second rule of exponents is the power rule. So when a power is raised to a power, we're actually going to multiply the exponent. So when we're multiplying, add our exponents. When we're raising a power, multiply the exponents. So x raised to 4 is just going to become x raised to 4 times 2, which is x raised to 8. Same thing, a raised to 5 times 4 is a raised to 20. 2 squared raised to 3, 2 times 3, so we have 2 raised to 6. Again, I have to evaluate this. 2 raised to 6, so I already know what 2 raised to 5 is, right? So 2 raised to 5 is 32. Multiplying that by 2, I have 64. Going quickly through these, the third rule of exponents deals with division. When like bases are divided, subtract exponents. And when I say like bases, I mean we have the same base. Looking at letter A, our base is x, right? So this is actually just understood to be x raised to 5 over x cubed. The base for both of these, the numerator and denominator, are x. is x. So we're just going to actually subtract 5 minus 3, which is x squared. And again, if you were to write these all out, 2, 3, 4, 5 divided by 3x's. This actually comes from the fact that they're going to be canceled out, right? So this cancels out this x, this cancels out this cancels out this, and you're left with the 2 on the top, which is x squared. That's how they got it, but because we know the rule, we're just going to be subtracting. We have y raised to 6 over y squared. Y raised to 6 minus 2, top minus bottom. And again, this only works through the same base. So y raised to the 4th power. This one I have 3 raised to 5 over 3 squared. Some people might evaluate the top and then evaluate the bottom, which is way too much work. Evaluate it first using the rules of exponents and then find its equivalent at the end. So there's going to be 3 raised to 5 minus 2, which is 3 cubed, which is just 3 times 3 times 3, right? So we have 3 times 3 is 9, times 3 is 27. Continuation of our third rule. We have something that's a little bit more complex, so I still have only one term on each side, but I have more than one variable involved. So first thing I want to do is just actually simplify my fraction. So 15 over 12. I know both of these numbers are divisible by 3, so I'll actually just change this to be 5 and 4. So I'm going to have 5 over 4, and then I have x cubed and x squared. That's going to be x raised to 3 minus 2, right? Then I have y cubed and a y. And again, it's understood that that exponent is 1. Y raised to 3 minus 1. I'll show you a different one later on when we're going to be dealing with when the bottom has larger numbers, but we'll get to that later. For now, we can just do the subtraction. So this is going to simplify to 5 over 4, x raised to 1, or just x, and then y raised to 2. It's important to note that exponents are only for the number that it's directly attached to. For example, the 2 with the y, the exponent of 2 is only for y, not for x, right? So it's only for what it's directly attached to unless you have parentheses and a single term inside. Moving on to our last and easiest rule of exponents. Any number or variable and non-zero raised to the 0 power is equal to 1. So anything raised to 0 is equal to 1. I'll show you the quick explanation of it with this x raised to 4 over x raised to 4. So I'll write it over here. I know that x raised to 4 over x raised to 4, that's just x times x times x times x, right? Over, we have the same thing on the bottom. And these all cancel each other out, right? So that actually comes out to 1, or any number divided by itself is going to be 1. So that's how come we get the same thing here, because I can just do the subtraction, right? 4 minus 4, which is x raised to 0. And as we know, it's just equal to 1. A raised to 0, same thing, 1. If you had a banana raised to 0, it would be 1. 10 raised to 0, 1. It could be a million. Raised to 0 is still going to be 1. 6x raised to 0. Remember how we said that the exponent's only for the number it's directly attached to? So this 0 exponent's only for x. 6's exponent is actually 1. So this is essentially 6 times 1, where this is equal to x raised to 0, right? So 6 times 1 is equal to 6. So this is one thing to be careful of. There's probably most likely going to be a question almost exactly like that in your test. Moving on to polynomials. So polynomials are just a specific type of algebraic expression with numbers, variables, and operations, like we have here. So terms of a polynomial are actually each of these little pieces, right? The smaller pieces that are separated by addition or subtraction signs, so plus or minus symbols. These are the terms of a polynomial. Factors of a polynomial. Actually, maybe we'll just call this a factors of a term. If I had the term 7x squared, my factors would be whatever's multiplied to get that product. So I have 7 and x squared. For 5x, my factors are going to be 5 and x, because 5 times x is 5x. Numerical coefficient is the factor of a term that's a number. So if I was looking at 7x squared again, my numerical coefficient is just the number in front of my variable. If I had a negative, like minus 3x, my numerical coefficient would be negative 3. Also, if you just have a number, 4, the numerical coefficient is just 4. So you don't necessarily need a variable. There are 3 basic types of polynomials that we're going to be looking at. Of course, there can always be more terms, but the ones we're going to be using more often are monomials, binomials, and trinomials. This really just tells you how many terms that the polynomial has. So obviously monomial 1, bi 2, tri 3. So examples of these might be 8x for a monomial. An example for a binomial could be 2x squared plus 1. Trinomial, 3x squared plus 5x minus 2. So again, the amount of terms tell you which kind of polynomial it's going to be. So now we're going to be looking at degrees. So when we talk about the degree of a term, it's the sum of the exponents of all of its variables. So let's look at these down here. We have 3x squared plus 2x plus 1. The degree of 3x squared, my variable is x. The degree is 2. For the next one, the degree of x is just 1. And if there's no variable, it's just a number, the degree is 0, right? Because it's just basically 1 times x raised to 0. This next one, we have 5x cubed. So obviously my degree is that, 3. I have 1 and 0 again. Looking at this last one, it says the sum of the exponents of all of its variables. So right now I have 2 variables. I'm actually just going to put a 1 here so I can remember that, right? Because it's understood to be 1, even though it doesn't say it explicitly. So x squared y raised to 1, the degree of this term, I'm going to add these 2. So it's actually going to be 3. And for the next term, it's going to be 5, because I'm adding 3 and 2. The degree of the polynomial, on the other hand, is just the highest degree of a term. So look at it, all its terms, take the one with the highest degree, and then that's the degree of your polynomial. So for this first one, 3x squared plus 2x plus 1, my highest degree that I have listed is 2. So the degree of that entire polynomial is 2. The degree of the second one is going to be 3. And the degree of the third one is actually going to be 5. So whatever one's the largest. Okay, so we're finally getting into addition and subtraction of polynomials. To do this, the first step we're going to do is get rid of grouping symbols. And by grouping symbols, I mean parentheses or brackets. And this is usually when we distribute a negative sign when subtracting. Next step would be to combine like terms, which are terms with the same variables to the same exponent. For example, if I have 4x squared on one side and 3x squared on the other side, I'll combine them because they both have x and they're both squared. So looking at these two, I'll just write it out. Minus m plus 4 plus 3m squared plus m minus 5. From there, I'll combine like terms. Some people like to write it vertically. You can do that if you want. Doesn't really matter. For addition, it's a little simpler, so you might not need to. So we have a 2m squared and 3m squared. I like to cross it out so I don't forget anything or I don't add something twice. And this will just be 5m squared negative m plus positive m. So negative m plus m, they cancel each other out. 4 plus negative 5 is the same as 4 minus 5, so you have negative 1. Looking at another example, we're now subtracting a certain thing from another polynomial. So I'm actually going to do minus negative 8c squared minus 9c plus 6. And again, we do need parentheses for subtraction. Okay, I'm going to distribute this negative sign. When we distribute a negative sign, we're essentially just multiplying by -1. So this is actually going to change the sign of everything in the inside. So I have positive 8c, so plus 8c squared, plus 9c minus 6. And I'll just rewrite the ones at the beginning. And then from there, just combine like terms. 11c squared plus 8c squared. We have 19c squared. -4 plus 9 is going to become plus 5c. 7 minus 6 is going to be plus 1. So again, we're really just looking at our numerical coefficients of our like terms and combining them from there. Another example we have here, we now have a trinomial plus a trinomial minus another trinomial. So I'll just write out what I can. When you have addition, you can just take out the parentheses. So I'm going to just do 5x squared minus 2x plus 1 minus 4x squared. I have a plus and negative, so I'm actually just rewriting without the plus in the inside because plus and negative is the same as minus. Plus 6x minus 8. Now I need to distribute this negative, right, to these three. So I'm going to change the sign of all of them. This will become negative, positive, and negative. Now I have these. It might be really important to cross things out. Again, if you want to write it vertically, do it, whatever works for you. So I have 5x squared, negative 4x squared, and negative 2x squared. 5 minus 4 is 1. Minus 2 is going to be negative x squared. I have negative 2x plus 6x plus 4x. A negative 2 plus 6 is going to be 4. Plus 4 is 8. Be careful there because some people might put 0 there, right? But just be careful. For this last one, I have a 1. I have negative 8 and negative 3. 1 minus 8, negative 7, plus negative 3 is going to be negative 10. So this is our resulting polynomial. So just be careful. Make sure you distribute the negative sign when you're subtracting. Otherwise, just be really careful to add and subtract correctly. Last example, we have 5x minus 3 minus the sum of these two binomials. So when I see brackets, that's just a big parentheses. So basically I'm going to do whatever's inside the parentheses first, and then inside that bracket first, and then subtract that from there. So I'm just going to work. So 5x minus 3 minus, we have in the bracket, I'll actually be adding these already. So x plus 2x. Again, when I'm just adding, I don't need to worry about the parentheses at all. So x plus 2x becomes 3x. 2 plus negative 6 is negative 4. From there, I'll distribute my negative sign. It doesn't matter if you still have a bracket or if you change it to parentheses. So this will change to negative 3x plus 4. I'm rewriting what I have at the beginning. I have 5x minus 3 minus 3x plus 4. Combining like terms, 5x, negative 3x, I have 2x. Negative 3 plus 4 is 1, so I'm adding 1. And that's it. Just kidding, there's one more example. Last one for real this time. 9a squared minus this whole thing. So again, I'm working on within the brackets first. Rewriting this, 9a plus 2 minus, brackets or parentheses, that's fine. Okay, so I needed one more step of distributing my negative. So I have 7 plus 3a minus 4a plus 5, changing the signs of both of those that I'm subtracting. Okay, from there, I'll simplify what's in this bracket. 3a minus 4a is a negative a. 7 plus 5, we have 12. Over here, 9a plus 2 minus that. I'm going to do one more step of distributing the negative, changing the sign of these two. So I'm going to change it to plus a minus 12, rewriting what I have in the front. Okay, this is 9a, not 99, plus 2. Combining like terms one last time, I have 10a, negative 2, or 2 minus 12 is going to be minus 10. So students, I really encourage you to do the practice problems for this section, as even though it's a pretty simple section, it's one where people tend to make very careless mistakes. So just be careful, check your work, always practice, get your brain back into the habit of doing math. So yes, I will be sending out part 2 this week. Good luck and have a good day.